Hello friends, welcome to VLSI Techno. In this video session, I will tell you post layout simulation and finally tape out. If desired specification is met, so continue the session. Okay, so this is my inverter test. Okay, so now I started, and this is my inverter schematic. Before going to post layout simulation, I show you something here. Firstly, double click on go to descent edit. Okay, here now we done our pre-layout simulation. Firstly, so this window will come. After that, we can load your previous state. So I have already loaded here previous state. So this is my previous state, and then after run it. After running the simulation, the result will come transient response and DC response. This is a pre-layout simulation or only simulation. So when you look at this netlist report, so here is in circuit inventory only show node and source. There is no any resistor or capacitor, so that we can say it is a pre-layout simulation. One important thing I want to tell you how to show your region of your component. Here is only two components, so you can show the result of two component. If you are in schematic, if too many component in your schematic, then how can you display? So for display, you have to run DC analysis. It will must. Then after it will show your component property. To show the component property, after the analysis of DC, you go to view and go to annotation and go to setup. Okay, this is a Virtuoso 6.1.6. so in Virtuoso 6.1.6 and after the Virtuoso 6.1.6 in view option there is a annotation and then there is a setup, but in 6.1.5 there is no annotation, and that version has a display component option. Okay, so this is 6.1.6. so this one annotation setup, go to here. This is already selected library and PCL. So what you want to show, just go select. You can only select here 4 parameter. Then you selected here just like I want to show you. There are too many options. You want to show region, this is region. If you want to show there, VGS. You can select 4 option here. You can select any one. I select threshold, apply. Okay, you can also change NMOS and select here. So already selected some region, threshold and length and multiplier. Okay, press OK. So it will show here the region and multiplier and threshold value. Okay, so now we go back by pressing Control E, automatically go to back. Okay, so this is showing inverter test. Now we go to this one, inverter schematic. Okay, in this schematic, firstly we go to layout already designed in previous tutorial. So this is the layout. Open it. After opening of a layout, I have already tell about DRC, LVS and PEX. In this layout is all clear of any error of DRC, LVS. So if you want to show the component, just press Shift AF, so it will show the internal structure. If you want to back, just press Ctrl F, Shift F for display the internal structure, and Ctrl F for disabling. It will show only name. So I am showing the component. Then here now we go to post layout simulation. Before post layout simulation, we again run this specs. Actually here I am showing a tool, Calibre tool, a special property by which you can directly do post layout simulation. There is no need to create a test bench or other. But for this one you have to save your previous state. So this it is very important. If you have a save the state, then it will show the post layout simulation result. And now okay, so I have already tell about this how to run DRC and LVS and parasitic. So I am again running this one, PEX, to show you how to do post layout simulation with this PEX running. You can watch here, this delay is 59.6886. After the running of post layout simulation, this value will be changed. Okay, you can here append option, it will create two file. Okay, two waveform. Here is we make, you can want to change, you can change the name, otherwise leave at it is. Now here we have to choose this one option, generate expected netlist. Hit on and click OK. Close it. There is no error. Okay, automatically a window will come here. This one is, when open this window, here is name, show name Calibre. So it will show the your post layout result. Before doing running, we can load your state. So I am already you can load this test in order test state and run this. So after running this, it will show your result. Here is not showing. Okay, this is a Calibre tool netlist generated property. So now run this one to show the output of this one. Only selected input, so that is showing here. When you look at this file, netlist file, okay, open this one. Here it show in this one, here capacitor register had added extra, so that it's showing post layout simulation. This is method to run post layout using Calibre tool generated netlist file. Now we use Cadence Virtuoso tool to show the post layout simulation. So there are two ways to show your post layout simulation. actually three ways. So this is the first way, uh, by using Calibre tool generated file, netlist file, to show the post layer simulation. This is the showing post layer simulation. Now I am using this uh, Virtuoso tool to show the post layer simulation, to do the post layer simulation. So just here is the name of Calibre. When open the, just close it. This is my pre-layout simulation of inverter, this one. Now run post layout. When okay, so I run again this one to show the difference. This one. So when I just zoom it and point the maximum value, this one is the maximum value. Just zoom it to get accurate. This one the accurate value of pre-layout simulation, and this is the delay. Okay, now run post layout simulation. So this is a method, by using just changing an script in environment, you can show your post layout simulation. So what value you have to show, what is extra script is written here. Just go to tool, library manager, and open this your library where you generated. So this is the our Calibre file, which is packs in this file, packs and internal resistance and device and input output pin are available. So just what I do, just copy the this name. You can put any name. So just copy it and paste in environment here. Paste, or you can write here and just paste. Okay, so I am adding here only Calibre name of this file and press OK. Now run this. Okay, in this file we have changed. You can look here is the file name. Okay, now run again. Here you delete this one. If you want to append, if you replace, then it will go on. So we check append, or you can check. Okay, append is good. Now click this one. Okay, so firstly we look at this one. Here we just know this is pre-layout or post layout. We will look at this file. This one, circuit inventory. Here is we added capacitor and resistor. So this is a post layout simulation. Now look at this delay. Delay is increases. Previously delay is 59.6886. Now after the post layout simulation, delay will increase and it is 61.5634 pico. When you look at this transient response, here I put the marker. So just zoom it. Here is to name of file. Actually not to maximum zoom here. Difference very little, but the difference in delay clearly show here. This one. Okay, this is the second way. Now third way is just go to Virtuoso and tool manager, or you can go to here file, any option, just go to click your library and your cell name and just go to file, new, and cell view. This is inverter test. Just go to this one, type and choose configure. So this is configure and click OK. After the clicking, it will now show a new configure here. So just go to here and just choose schematic. After that we go to use template. Here we select a spectre or play OK. It will show here. Now press OK. After pressing OK, it will show here. Just right click here, it will show the different here. Okay, so firstly go to click on Calibre and click this one file. This one file. Okay, and now press OK. So this file is created, a new file configure in this library manager. When you look at, just click on it, it will ask, so click on yes, both option. Okay, so it will come here. Now go to launch and take the previous step, this one, state. Okay, this is the pre-layout already. Actually I am loaded pre-layout state, so it's showing pre-layout value. Now run this. After running, it will show the post layout simulation. So we check here, this is pre-layout and post layout. Just go to circuit inventory, this one. So it's showing post layout simulation result. And when you check out your delay, in this one, this is showing the value, post layouts and value 61.5634 pico. So this is post layout simulation. Okay, so today in this here I am tell you 4 way to do post layout simulation. First one is by using Calibre tool, and second and third is using Virtuoso. So here is in Virtuoso, firstly we directly in second method of post layout simulation, just open the your this one test schematics and change here in environment and make the name and run this. So it will show the post layout simulation. And the second method is you to choose type is configure. Here just go to tool, library manager, and make a configure file. Then after run this, this one. So here you can select pre-layout, post layout both, but just selecting if you are selected Calibre, it will show post layout simulation. If you are selecting schematic, it will show pre-layout simulation. Actually I may do physical verification through Calibre, so it will show Calibre name. If you are using a Asura, it will show AV tech, AV extract. So in same manner you have to just change the environment name, or just go to, if you want to use this configure configure type, so just do the follow this step. Here we will show the AV tech for Asura. If you are done physical verification through Asura, then it will show here AV tech. Okay, here I am using Calibre, so it will show Calibre here by using this one. Or you can just go to here, go to environment and add here AV tech for Asura. If you are using Asura, so just use here AV tech and press OK and run this. So it will show after that post layout simulation result. Okay, now I show you tell you how to tape out a sign off. If your post layout simulation get as desired specification or fulfill your desired specification, then you can move for tape out. This is final file generation tape out. So how to do tape out? So for tape out we have to require cell map file, object layer map file, and uh, layer map file. So just go to export and select stream. In stream file we already name here already show in the in test dot gds. So this is final file. Use select your technology. I am using here SCL. So this one automatically care name is coming here. Okay, now so option, in option we have to add layer map file or object map file or cell map file. So when you click on cell map, so you have to load cell map file. So cell map file is presenting here, this one cell map file. Click OK, so it will added. Now go to layer. So layer map file will be required. So for layer map file is presented SCL. Your technology file GPDK. Here is the choose your layer map file. So this is layer map file. Okay, and now finally the object map file is required. So just I'm searching. Okay, this one here. So this is the required object map file. Just go to again your pdklib file. And select object map file. Okay, every file is selected here. Okay, now here is the location root cadence directory. File will save name inverter text.gds. Now everything is fine. Just click hide and translate it. So it's translating. What is warning showing here? Okay, so actually I am selecting wrong file here due to this one. You have to select it, this one and layer. Okay, not schematic. Now run this. Actually I am selected all file. This is share my file. Okay, now everything is fine. Just run it. Here is showing translate completed with 0 error, or not stream out complete. So finally a GDS file will created. On here cadence directory. This is created file is inverted GDS. So this file is given to your foundry to make the layout on PCB. So this is a final tape out file. So this is a method to create a GDS file, and in this session of video I will tell about a postal simulation and GDS. So this is a complete flow from starting from schematic design, symbol design, layout design, their physical verification. This is post layout simulation, and finally GDS generation. So thank you for watching my video. If any query related to uh, Virtuoso design or in this video, just comment on my video. If you like my video, just click on like button and subscribe my channel. Thank you.